Common multiples lesson 22. So we're going to use multiples to help us solve some problems. Today's goal is I can explain what a common multiple is, I can explain what the least common multiple is, and I can find the least common multiple of two whole numbers. So let's get this down, get our page number and today's date, and let's go. Let's look at some multiples here. What are the multiples of 4 that are on here? Yeah, 4, 8, 12, 16, 20, 24. What about 6? 6, 12, 18, 24. So, if we take a look at this, we can obviously keep going and find more numbers that are in common between 4 and 6, right? But what's the least common multiple? What's the one that's the same in both, but it's the smallest? Yeah, it's 12 here, right? That's the lowest number that both of them have in common. So we were looking at factors last time. This time we're going to be talking more about multiples. All right, let's dig in. Get the florist's order. Okay, so a florist can order roses in bunches of 12 and lilies in bunches of 8. Last month she ordered the same number of roses and lilies. If she ordered no more than 100 of each kind of flower, how many bunches could she have ordered? Well, let's think about the multiples of 12. Okay, so 12, 24, 36, 48, 60, 72, 84, 96. Okay, what about multiples of 8 that go up 2 and no more than 100? Yeah, 8, 16, I guess it would help if I wrote 16 like you're supposed to. 24, 32, 40, 48, 56, 64, 72, 88, I'm sorry, 80, and 88, and 96. So, look for ones that are the same here. So we've got what? We got 24 for each, right? So you could have gotten 2 roses. Let me do that over here. I'm going to draw a little chart. You'll make it into another color. All right. Okay. So, I'm going to put my roses on one side and my lilies on the other. So for 24, I need 2 bunches of roses and 3 bunches of lilies. What else do we got the same here? Yeah, it looks like 48, right? Let's see, 48, that takes 4 roses, takes 6 bunches of lilies. Any others here? Looks like 72, right? Let's see, that's 6 bunches of roses. That is 9 bunches of lilies. And we can do 96 as well. That's 8 bunches of roses and 12 bunches of lilies, right? Because this would be 24 for these, 48, 72, and 96. So what's the smallest number of bunches that you could have possibly ordered? So she's going to order them together because she needs to have them an equal number. The smallest that she could have bought were 2 bundles of roses and 3 bundles of lilies. Now, obviously, they could have gone down to just 1 bunch or some sort of part, but when we're talking about whole numbers is what we're really looking at here and how those whole numbers relate. So since that is our least, I mean, that means we get, 48 total flowers. That's 24 of each one, right? So if you're doing something where you need both the same, it would make sense to buy just 2 bunches of roses and 3 bunches of lilies because you're trying to make the same amount. And in these other cases, that works as well. And, you can certainly keep going up. It's kind of like factors. You could keep using all the possible factors, but you're going to need to look at what the situation calls for. All right, let's talk about least common multiple. So what do you think common multiple of 2 whole numbers is? Yeah, we just talked about it, right? It's 2 numbers that 2 different numbers can make. So if we look at this one here, we have the least common multiple of 6 and 8 is 24. How? Why? What does that mean? Well, that means that if I look at the multiples of 6, and I just keep rolling on with those, and I could keep going. Same thing with 8. The reason why we say that 24 is the least common multiple is that it is the smallest number that both 8 and 6 can make when you multiply them with something else. So that is the least common multiple for both of them. What about if I looked at multiples of 10 and 8 that are less than 100? What do I get? To process. So I've got all my my multiples of 8 up to 100 and all of my 10 up to 100. So what's the least common multiple between both of them? Well, the least common is 40, right? You can multiply both those numbers by something else and make 40. 80 is also a common multiple, and we can keep going up and up and up, but as far as least common, we have 40 and 40 for each of them, with 8 and 10 being their main parts. What about multiples for 7 and 9? What are the least common multiples there? This InstiSolve, when you don't want to listen to your teacher take a long time in a video to put something up. So for 7 and 9, these are all the possible multiples. If we look for the least common multiple between them, it's not looking pretty. There's a lot of stuff that's not close, is there? I mean, 27 is close to 28, but that doesn't work. 36 is close to 35. But no, it looks like 63 is the least common multiple. And those are the things that you get when you multiply them together, right? Sometimes the least common multiple, because of a particular number, is going to be something pretty low or pretty high, because both of them, they're unique numbers that really their least common multiple is to multiply them together. So when you think about like 7 and 9, 63 is the lowest that you can get. Everything else doesn't even match. I mean, you've got to go past 100 to find anything else that matches. Even numbers, a lot of times you can find smaller things because they have certain numbers in common, which they always have 2 in common, since that's why they're always even that way. But when you talk about odd numbers, it gets tricky. It just depends. Let's jot this down. A common multiple of 2 numbers is a product you can get by multiplying each of the 2 numbers by some whole number. I would definitely make sure I wrote down an example. So 30 is a common multiple of 3 and 15, because 3 times 10 makes 30 and 5 times 6 makes 30 as well. Both of those have factors that are 10 and 6 that make them work. Multiples of 3 are 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 5, so I know 5, 10, 15, 20, 25, 30, 35, 40. So common multiples between them would be 15, 30, 45, 60. Those would be the common multiples for both of them. The least common on both of them is going to be 15, right? And again, it's just like I talked about with 9 and 7 a second ago. That's the number that you get that when you multiply them together. So sometimes it is just a number that you multiply them together to get, but not always. That's why you kind of need to check. Prizes on a grand opening day. Lynn's uncle is opening a bakery. On the bakery's grand opening day, he plans to give away prizes to the first 50 customers that enter the shop. Every 5th customer will get a free bagel. Every 9th customer will get free blueberry muffin. Every 12th customer will get a free slice of carrot cake. If Diego's waiting in line and is the 23rd customer, he thinks he should get farther back in line to get a prize. Is he right? Yeah, 23 is not a multiple of 5, 9, or 12, so he's going to have to move. How much further back does he need to move? And he only needs to move back one place. He needs to move to 24, right? If he's the 23rd, he needs to move 24th. Why? Well, 24 is not a multiple of 5. It's not a multiple of 9, but it is a multiple of 12, so he doesn't have to go back too far. Jada is a 36th customer. Is she going to get a prize? Yeah, she's going to get a prize. What's she going to get? Well, let's look. 36, is it a multiple of 5? Nope. It is a multiple of 9, so she's going to get a blueberry muffin, right? Blueberry. What else? Was that it? No, she's actually going to get the carrot cake, because 12 is a multiple of 36. So she's going to get a blue carrot. Wait, what? Nope, she's going to get a muffin and a slice of cake. So is it possible for her to get more than one prize? Yeah, well, because remember we said that the way they've got it set up, every 5th customer gets a free bagel, but every 9th customer gets a free blueberry. Well, there are certain numbers that all of these have in common that they're going to end up getting the same things. So that's how that works out. What about, do you think, how many prizes in total is Lynn's uncle going to have to give away? Well, let's think about all the multiples up to 50 for each of those numbers. So 5, 9, and 12. So you can see there's going to be, not only do we talk about how muffin the cake if you're the 36th, because 36 is a common factor or common multiple for 9 and 12, but there's going to be other times, right? 45 and 45 here. So there's going to be a few people that are going to actually come out with multiple prizes. So you're going to need 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 prizes to do all of this total. 4 total of the carrot cake slices. You're going to need 5 total of the blueberry muffins, and you're going to need 10 total of the bagels. Okay, and there's going to be those fortunate few that they're going to get 2 things. When we get to 45, someone will get something twice. When we get to 36, somebody will get something twice. The least common multiples, as you can see there, can kind of help you out to get multiple prizes if you're in a situation like that. And a lot of times we use least common multiples when we're talking about converting fractions so that they have a common denominator. So a least common multiple means that it is a number that 2 numbers can make, and it is the smallest number that 2 numbers can make. When you talk about, like, let's say 4 and 2. If I wanted to find the least common multiple between 4 and 2, it's actually 4, isn't it? Because 4 times 1 gets you 4, and 2 times 2 gets you 4. So 4 is the least common multiple for both of those. You can list them out, and you can start listing them by the multiples, and just the first time you see both of them the same, then you can stop there. Holy Toledo, we are quite a bit over, so I'm going to cut off there. Thanks for watching.